Okay, we're going to look at the gravimetric lab and some of the parts that are going to go along with that. So you have three main equations on your sheet, if you take a look at. And the first equation is just looking at this group 1 metal carbonate. That's what we're trying to identify. What is that group 1 metal carbonate? And the ones we're mostly going to be thinking about for that would be lithium, potassium, or sodium. You got cesium and rubidium in that group too, but we're not going to worry about those. Remember that hydrogen is not considered a group 1, even though it's in that column. So our characters could be, M is not a metal or an element, it's just the metal we're trying to figure out. We are trying to figure out, is it potassium, lithium, or sodium in this mysterious position? So ultimately, we want to figure out what the identity is by figuring out what the molar mass is. So we have this equation, and being a group 1, something that you should just know is that group 1 metals are always soluble. So when I take a group 1 metal in combination of anything and you put it in water, it's always going to dissolve completely. So group 1 metals always dissolve. So if I take this, put it in water, it becomes aqueous with these guys here. And this is kind of like the balanced chemical formula for that, dissolving in solution. This one here, if I take this solution and carbonate is present, where group 1s are almost always soluble, carbonates, as the anion, carbonates usually are not soluble, usually, unless it's with a group 1. But if I put calcium into this solution, calcium chloride, if I put calcium in the solution, it's going to combine with the carbonate and precipitate. You'll see like this chalky stuff, chalky stuff kind of going to the bottom of the container. So these guys are going to combine and form a solid. So this is our big equation right here. We're going to take a solution of excess calcium chloride. It's a solution. It's clear. You're going to take this solution and mix it with another clear solution, the metal carbonate. And with this combination, when you mix them together, you are going to get the precipitate that we talked about up here. So this is going to go to the bottom, and these guys will stay in solution. What we are ultimately trying to figure out is what was the molar mass of this. So we have to figure out what stuff we know. And this is something that I use as a reference to figure out other information. So one of the questions we would have is, okay, well, how much calcium carbonate did I have? I already mentioned it's in excess, so I'm going to write down some numbers just so I know kind of what I have. And I would advise you to do the same. It doesn't have to be these numbers, it just so happens to be here. So calcium chloride, I have 125 mils, and according to the lab in front of you, this is the concentration. About 0.2 molarity, 125 mils, about. It's in excess. It doesn't matter a whole lot as long as you have enough. With the metal carbonate, I am measuring somewhere ballpark, and I may change your numbers specifically, but it's going to be somewhere in the ballpark of around 2 grams. That's it. So you have 2 grams of the stuff, and I'm going to put it in solution. It's going to dissolve. And then I'm going to mix this in. What's going to eventually happen is you're going to get a precipitate of some number of grams. So what I need to do is gather this into filter paper. I'm going to filter it through like a funnel into some filter paper and gather this mass. I'm going to take it in the filter paper. I'm going to dry it out, drive off all the water. What's left will be some mass of calcium carbonate. If I know how much mass of calcium carbonate I have, I can therefore turn these grams into moles based upon the molar mass. You would have to figure that out. What is the molar mass of calcium, carbon, and oxygen? 3 of them. Rolling all that together, I can go grams to moles. If I know the number of moles of calcium carbonate, I can use the stoichiometry to figure out the moles of the metal, mysterious metal carbonate. If I figure out the mole-to-mole ratio, it's right there. Do the mole-to-mole ratio, I will have the moles of this metal carbonate. If I know the moles of metal carbonate, and I know the mass of the metal carbonate, does that turn into? You therefore have the grams to moles of the metal carbonate. And with this information, that is the molar mass, which tells me who it is. Now don't forget, that is the molar mass of the metal carbonate as a 2. What I need to do is subtract off the mass of the carbonate, which would give me only the molar mass of 2 metals, divide by 2. That would give me very specifically the molar mass of that particular group 1 metal. That's exactly what I'm looking for. Who is this mysterious group 1 metal? That's it. So in the next part of the video, I'm going to show you kind of the procedure that we go through to set this up. Good enough.